Everyone, it's Mr. Wolfe here, and in this video I'm going to be going over scenario number 5. So in scenario number 5, imagine that I have a note card. So let me just grab like a piece of paper, I guess this one right here, and that on the note card I have some type of penny, and then I'm going to flick the note card off really fast, and so the question is, well, what's going to happen to the penny in this case? So, and I'm going to first draw a model of what's happening with the penny. Oh, by the way, I do need to make a claim in this situation. But let's say I just don't know what's going to happen yet. We could use the model to help us figure that out. So in this case, I'm going to say that we're on Earth, so I'm going to have a force of gravity on the penny, a normal force by your finger pushing up, or actually the note card pushing back up on the penny. Those are going to be equal. And then here I have a force of gravity acting on the note card, and then the normal force acting on your finger pushing up on the note card as well. And those are going to be equal too. Now, it says in the scenario that you're going to flick the note card, so you're in contact with the note card, applying a force to it. Right? It also says neglect friction, so don't worry about friction right here. And in terms of the penny, you're not flicking the penny, so there's no applied force on the penny, nothing really in contact with it. So this is going to be our free body diagram. So hopefully after looking at this, you can kind of realize, okay, we're going to have a zero net force here, because there's either no forces or they're balanced, which means I have zero acceleration. But here I have an imbalance going to the right, so I'm going to have a net force here, which means my acceleration also has to be going to the right as well. So hopefully after making these free body diagrams, you guys can make the claim now that the note card increases velocity, right? It changes its velocity, and the penny will remain at rest. And if you were to actually test that out, you put a penny and then in between the note card, you flick the note card, the penny would just stay on your finger in this case. It's really just like the plate demo. So if we look here in terms of our explanation, here's the logical progression we want to go through. What's the object's motion beforehand? Explain relevant forces in a free body diagram. Is there a net force? And how will this affect the object's motion? So first off, beforehand, the penny is at rest. That's what it's doing beforehand. And as you can see in my free body diagram, the penny has no forces acting in the x direction, so there's no net force. Right? So at this point, I've actually hit the 3 parts of my logical progression. So then as a result of that, you want to say, okay, well, with no net force, the penny stays at rest. Right? And that's it. Right? Notice that this one's a little bit less complicated, but this one would work too. Right? I usually like giving a little bit more explanation about Newton's first law, but you actually hit all the points with this one. All right, so let's try so this is the explanation for the penny. Let's talk about the note card. So beforehand, the note card is at rest. Right? And then as you can see in my free body diagram, the note card experiences a non-zero net force because the applied force is greater than the force of friction. So maybe I actually don't remember because I don't have the packet with me right now, but let's say that if there was no force of friction, we wouldn't draw a force of friction. But let's say that there is a force of friction. We'll draw it right here. Right? And as long as your applied force is greater than the force of friction, you're good for this scenario. Okay. So then all I need to do now is I know that there's a non-zero net force because of my because my applied force is bigger than my force of friction. So then my conclusion is that the note card will change its velocity by increasing its speed. It was at rest. Because it experiences a net force, it increases velocity.